Okay, stream should be on. So, welcome to Automat Live Coding. On this stream, we are programming, mostly C++, a tool for playing games. The tool is called Automat. This is how it looks. You cannot see it yet, but this is how it looks. It's a virtual canvas, or like a desk, where you can drop toys, all sorts of toys. And you can hook them up together and they can do different things. Like this one, for example, is a macro recorder. You can use this one to record macros. Very handy for automating games. Whenever a game has like repetitive manual element, it's probably going to involve a macro. So I can record a fancy mouse movement. It also recorded the mouse press at the end, but I don't need that, so I will delete it. And when I play this, you can see what happens. Mouse moves on its own. Crazy. You have other utilities like timers, hotkeys, so that I can configure my macro to fire whenever I press space. And you can see the feedback immediately. So when I press space, this blinks. It means that it's sending a signal. So now I can hook this up like that, and I press space. My mouse makes this funny movement. I can trim this macro because it's could be a little faster. So now when I press space, my mouse immediately performs the motion. There are plenty of things that would make this environment even nicer to use. And we are slowly, progressively adding them in. Recently, I've been playing this game. This is a programming game, essentially. In this game, you are writing programs that play for you. But there is one element of this game which cannot be automated by scripting. And there is a very specific minigame here called infiltration minigame. I can go to some place, try to infiltrate it. Okay, this is going to kill me, but I can... Let's maybe come here. This is a place where we can infiltrate super easily. So here I have to select a nice thing to say about a guard and press space. Now I have to press space when the guard gets distracted. Now I have to memorize the shape and select it again. Here I have to close the braces. Okay, and as you can see, it repeats. Most of those can be automated with Automat, but it's on the border of what Automat can automate. So my plan is to try to automate as much of this as possible, and if Automat recognizes a game that it doesn't know how to play, it can always cancel the infiltration and try again, because they are always picked randomly. So eventually we will luck out and Automat will play through all of the minigames. And each of those gives us the ability to trade reputation. And reputation is the main limiting factor in this game. See, right now I am gaining reputation at a rate of 1.8 per second. Slightly lower if I don't have this if. Anyway, infiltrating is like a great accelerator. It's giving me something like 5 minutes of waiting for a single infiltration minigame. So if I can teach Automat to play those minigames, it's gonna be amazing. So we've been improving the scripting capabilities of Automat recently. Scripting capabilities of Automat are kind of... Automat is using assembly for scripting, so you get access to registers. Oops, what icon even? I can select registers. So this friendly axolotl is actually a symbol for AX register. This is, probably guess, this is a stack register. This is the stack pointer. Anyway, when I have a register, I can write to this something. Here I have a deselect this. Here I have a capture of the game. Again, everything in Automat. I can do OCR on this. This is an object for doing OCR. We've been doing something similar during the last stream. I can select this section here, right here, and this detects start. I don't know why there is dot at the end. It doesn't matter. I need to write somewhere the result. I can write it into this register. So now when I run this, our register has some value in it. Supposedly it says start. But you cannot see this, you only see hex numbers, and this is what we want to fix today. We do not want to see hex numbers here, we want to see something else. What? So here come instructions. So the way that instructions deal with this is that each instruction that can be parameterized, for example, here is an instruction that will compare array_x with something. I can run it. And you cannot see the result. I need to add a jump. Here. So here is an instruction which will first compare the values of EAX with 0, and then the next instruction will jump if the values were equal. It's not jumping, this is the connection for jumping. So I need to write something here. Do I need to write? Yeah, I would have to guess what kind of number the value start corresponds to, which is very hard. It's doable but hard. So there is a possibility of switching input modes here. So this is hexadecimal mode and this is ASCII mode or Unicode, UTF-8 mode. Here I can type start. Actually I can type only 4 letters because only 4 letters will fit in the register. But you can see they are the same. So this 53 corresponds to this 53 here. There is 74 here, which corresponds to this 74. 61 to this 61 here. 72 to 72 here. And now when I run this, it will jump because they are equal. So this way in Automat you can compare values. And this way of doing programming is maybe a little bit cumbersome, but we're doing everything we can to make it actually faster, nicer, more convenient, and pimping out registers is another thing that we will do today to make this even faster and more convenient. I have been for a long time promising that I am going to add some fancy animated flags to Automat's assembly subsystem, and we will try to do this today. I was thinking how they could look, and I have some notes. Not sure if I can show them, if they will be readable, but we can try. Anyway, so this is roughly what registers are going to look. I think here is the intended appearance of registers. They will have, instead of being a simple checkerboard like they are now, they will be turned into a wavy flag that turns around and flows like that. The left section of this flag is going to be draggable. So if you want, you will be able to stretch a register so that it's more horizontal. And you will also be able to grab on the top to resize the size of the register, because you don't always want to have the full array_x. Sometimes maybe you just want EAX or even shorter subregister. So we want to add those two draggable sections. Then I think we might move the icon from here over to here. Not sure, still not sure. And we definitely will have an editable field somewhere here where you can edit the value of the register. So that's the plan. yeah. So I wanted to play this big burner a little bit more, but don't worry, we'll do this eventually. Today we just have to pick one thing to focus on, and today those are registers.
Meister Chica says,
You accidentally become part of Linux Foundation.
Interesting. I do not know what this means. Hi, by the way. Okay. So we'll be coding some graphics code. Unfortunately, graphics code is something that AI just cannot do. It's so bad at it. So this is something that we have to do manually. Let me figure out what do we store inside register widget. Okay, apparently it's not even in this file. Maybe I should call this register toy. I'm not sure. I have this toy terminology. Anyway. Actually, the thing is, each object in Automat has a widget or a toy on screen, and the toy or widget on screen only contains the visual / animation / ephemeral aspect of an object. So if it's deleted, it can be recreated basically for free. So all of the persistent state, if we want to keep, we should keep in the objects. I'm just checking what state does the register widget have, and it doesn't have any state whatsoever. Okay, that's fine. It's only going to store the animation state anyway. Register. I also think assembler also should be probably redesigned. I don't know how assembler should look, but I think assembler should display the register in some very simplified default form and allow you to extract those register widgets, and register widgets will have more specialized tools for example, editing data or presenting data as different formats. Anyway, so what state does the register have? It has index, it has a pointer to assembler, and that's it. This register index, I wonder, its index in what units does it count? Okay. This is using this array. Okay, so we have this array called register presentation, and the register index uses this array to identify the register. Let me quickly So we will have to put more stuff here. First, we want to store how wide this register is. Is it like 2-bit? But maybe not 2-bit. 2-bit is going to be kind of fine. But I guess we can squeeze the register down to 4 bits. Actually, this is interesting. Maybe I should allow individual rows to have different width. That would be nice for bit fields and other such things. But okay, let's for now edit them jointly. So let's call this wrap position. Actually, why enum? I can just put a number here. The important thing is that this number must be even for the register coloring to work nicely. And just a visualization that I picked is going to need it. Anyway, we also should store the width of the register, because this register index it always identifies a full width the machine register, and sub-registers are smaller. And there can be lower and higher registers here. Okay, interesting. Yeah, I guess this should be fine. So those are two values that we will be able to play with, and each of those values needs to be animated. And a pretty decent workflow for animations now. So I just need to pick what kind of animation I want, and I think something springy would be nice. If I find my Spring V2, I remember I had some code for doing animation offsets or deltas, something like that. So normally this value would, this would be just a floating point equivalent of this value. But the idea is that when I'm dragging stuff, I want to immediately update the behind-the-scenes representation. I do not want to animate the register when I'm holding the mouse and update it when I release it. I want the update to be immediate as you are dragging it. Offset. Should I call this offset? Delta? If? Yeah, anyway.
URL.
So. I have silenced my... Yeah, okay, I will. And let's see.
Is that the new you? Coming in hot, look what we got. Are you ready?
By the way, I was complaining to Skia developers that Skia should really include, when you're doing a stroke, shader parameters for the perpendicular and the distance along the stroke, so that shaders can properly draw those fancy effects. They didn't like the idea, but I think this is just a matter of time until they finally add this, because a lot of those effects, they require proper UV coordinates in strokes. Skia doesn't provide them yet.
Redraw is using Skia dot.
Yeah, I guess probably converting everything to meshes. But some of those effects, there was, for example, variable blur somewhere. Not here. Oh yeah, I think it was here. Here. This is actually decent. So normally this variable blur is kind of hard to achieve properly, because the blur radius has to change as you are shifting along this axis. And what most people do is they have just one blurred image and one sharp image, and they blend between them.
URL.
That full introduction to your curve.
By the way, I think I remember this guy. I think he is... he used to work on React Native. Something like that. Object not supported. Do I have to open this in Firefox? Maybe now it will work. Object not supported. Okay. Cool find. Thanks for sharing. Variable strokes. This is interesting. because this implies some... Skia doesn't really expose variable stroke with any primitives to do this. This is interesting. I do not know how to do this. I mean, there are ways to do this, but they require some CPU side kind of meshing. So you have to create a mesh on the CPU and then upload it to the GPU. Very cool.
I was having lunch at office after filling sick leave papers. Saw that video. I was like, guys, we are going Skia once I'm back.
So, from the cursory looking, it looks like there is some tessellation step that's being added here. And this tessellation probably can introduce some extra vertex values. This converting of TypeScript functions, I guess this is just some simple translation. I'm not sure. Maybe it's some kind of AST thingy. Not sure. Vector feathering. Soft distance-based blur. Yeah, so I remember this guy from Skia discussion groups. He was exactly in the same position as me. He was asking Skia developers if they can help him get some... I think he was working on this variable blur. And this variable blur, vector feathering. Interesting. Vector feathering. First time I hear this term. I'm just a little bit worried I don't have this web GPU thingy. Yeah. It's not going to work.
If you can do that in React, you can do it in CP.
I think this React Native is mostly CPP. It's just, it allows you to just use TypeScript to write apps. But it's no different from a game engine, really. It's like Unity. React Native is basically a tiny game engine for web developers. Okay, these distortion effects, they appeared recently, or they're actually they existed for a long time, but they were popularized recently by Apple, because Apple introduced some transparent elements into their UI, and now everybody tries to imitate them, which is funny because it's a terrible idea to have transparent UI interface. But yeah. This distortion is actually super easy to achieve. When you are drawing, you can sample the texture onto which you are drawing, and you can blur it, you can displace it. There are SVG filters for doing this. They can do all sorts of fancy stuff. Yeah, I think those variable strokes, they probably use
$11.50. In video is what sold it to me.
Let me check. Oh yeah, I lived there for like 8 years. This is a bar in a hipster part of a city.
Hello React Native developers, I hope you are well. William here, recording from beautiful Zurich, Switzerland. I have something so special to show you this morning. And well, let's just have a look. 6 years ago, we were running the Can It Be Done in React Native YouTube series, where we were puzzling our way towards A-grade user experiences using the little to no graphic primitives we had.
Yeah, now I remember more and more. He is making amazing visual effects.
To think of it, the show was running under a simple premise. The bigger the obstacle, the bigger the fun. But eventually, we need to go from playing with the obstacle to overcome it completely. And with Christian Folk, we brought Skia to React Native. You have used it to build award-winning user experiences, and we are building it to follow the symmetry with the web, which led us to Web GPU, allowing us to compose nicely 3D scenes and 2D scenes.
Yeah, so the nice thing about Vulkan and Web GPU is that maybe I do not know much about Web GPU, so I shouldn't speak about this. My assumption is that it's very similar to Vulkan. But with Vulkan, you can very easily hook up your own stuff into pipelines. It's very plug and play. And the GPU and drivers will you just need to put the right semaphores between steps. You need to make sure that the buffers with textures are ready, and you can hook up basically completely different library that will do your UI and completely different library which will do the 3D rendering, and you can composite them and everything can work smoothly, responsively. You still have very tight control over scheduling because of the semaphores and fences. Vulkan is a really nice API once you get past the window setup stage.
These scenes together. And that was phase one of the project, to bring web graphic primitives to React Native. Once we had Skia in native, we realized that what we had was much better than web graphic primitives. On the web graphic APIs are completely siloed with one another. SVG, shaders, Canva 2D. This is when we started to work with React Native Skia Web, allowing us to have a unified API between all these important graphic primitives, allowing us to build, for instance, incredible graphic motions using Remotion. And that was phase two of the project, to bring native Skia API.
Yeah, this is very fun because they bypassed HTML standardization this way, because Canvas API is a web standard. You cannot expand it. Even if you add custom prefixed functions, it's like clunky. Browser developers, speaking from personal experience, are reluctant to add features that you ask them about. So what they are doing, you can do this if you download Skia. You can compile it in a way that compiles it into a WebAssembly module. And this WebAssembly module allows you to then run proper native Skia on any browser which supports WebAssembly. So you're essentially shipping your own rendering engine as a WebAssembly blob.
Back to the web. So we went.
So this is Skia native. It's part of Skia.
Web to native to bring these nice graphic APIs, and then from native back to the web to use the nice.
I think it was called. That's Skia. Anyway, you can just compile it into WebAssembly blob.
Skia API. So, what are we gonna do now? Go back to all the work we've been doing so far was done under one assumption. One maybe fatal assumption. We assumed that web graphic APIs, as siloed as they might be, represent a full set of 2D primitives. But do they really?
Exactly.
On the web?
This is such a big problem with Canvas and Skia, and they just only expose a very tiny subset of what is really possible. Like, for example, control over stroke, like the rasterization of those UV coordinates. When a stroke is being drawn, you want to get the position. If you want to have this nice, for example, expanding stroke animation, it can be done super efficiently on the GPU because the tessellation shader can just, compare two numbers. Oh, for example, the tessellation shader knows about the full shape, but it has parameters that say that, this point is, for example, 50 centimeters along the line, and the current animation is only 38 centimeters in, so it should not be drawn yet. And that's why you can do those things on the GPU.
You can set a stroke and a fill color, and that's pretty much it. The stroke width is a fixed scalar value. It's not really possible to have the stroke width be variable based on geometry information, like in this example where the stroke width is based on the tangent of the path. And the access of geometric information you have is very crude. For instance, you can shade the path using a linear or radial gradient, and that's pretty much it. You cannot have a gradient follow the arc length of the path, no.
This is like spot on.
And it gets worse.
It's unlocking so many cool effects, this thing here. And I was requesting this feature like 2 years ago.
That geometric information, as crude as it might be, at some point in the pipeline gets completely lost. In SVG, image filters are arguably the most powerful feature.
For instance, in Automat there are cables. Those cables, the way we animate them is that on the CPU, we are basically converting a cable path into a mesh. So this is how cables work. And this is why we can do this sort of shading. So this is basically a line, but we can shade it realistically because we have UV, we have distance along and distance across the line.
And they rely 100% on raster information, which is somewhat ironic because SVG stands for Scalable Vector Graphics. This is an example of a user interface heavily relying on a large amount of raster blurs. That interface can get very slow very quickly. And on the right side is the same user interface where the soft shadows are computed purely based on vector information.
This is cool. I am sold here, honestly. It pains me a lot that blurs are so expensive in Skia. Skia has to rasterize and walk over the image with some kind of filter to do the proper blur.
No rasterization step, just a single render pass running at full frame rate.
Yeah.
And of course, using vector-based blur, you can build advanced effects which are simply not possible using raster blurs. One last example, if you'll indulge me, physics-based renderings. To build a PBR in SVG, you need to provide height information in the form of a bitmap. And that's really ironic because all you really need is plain, rich geometric information, nothing else.
Yeah.
The idea that we will go through a rasterization step here feels very awkward.
This is beautiful.
Finally, to build a custom effect, you need to use shaders. And shaders require you to use a specialized GPU language, which would be okay, but the mindset is completely different. In TypeScript, you issue drawing commands, and we take care of showing you the right colors at the right pixels. In a shader language, everything is flipped on its head. You get the XY coordinate, and you have to walk back the path to the color you want to achieve. So maybe here there is a gap that could be solved. And that's a taste of the problem space we are looking at. Crude geometric information, effects which are purely based on raster information rather than vector information, and custom effects which live on a completely different universe. So here's what we're going to do. This morning, I would like to introduce a new grade of 2D primitives for native and web. Thanks to Web GPU, these primitives are going to integrate at zero cost with existing libraries such as Skia and FreeJS. This will kickstart phase 3 of our quest towards delightful user experiences, and this is how it looks like.
Okay, we've seen this, but we can watch this again. I've seen some SDF artifacts on this card.
So, a new grade of 2D primitives, Project Redraw. Let me set the scene. Currently, we have 2D primitives which are extremely easy to use, but somewhat limited. And then you have GPU programming, which is incredibly powerful, but extremely hard to use. Our goal is to provide...
I wouldn't say so. I actually learned GPU before I learned Canvas 2D. You just need shader toy, and on shader toy it's about as hard as a Logo programming language.
an easy-to-use API a la Canva 2D, but offering incredibly advanced 2D primitives. Now, when fiddling with new 2D primitives, you have to start at the beginning with Hello World. And for me, Hello World was the PostScript tiger. Each curve you see is rendered completely in real time on every animation frame. Some of you have seen this example countless times, but now there is a twist. You can now apply all sorts of geometric-based effects to the tiger.
Nice.
These effects are based on the rich geometric information of the Bézier paths. Ah là là, les courbes de Bézier. They are in fact the heart of the matter when talking about 2D primitives. And there are two kinds of Bézier curves: open paths and closed paths. Let's start with open paths. I have my SVG path here, and I can set a stroke width. So far so good. But now, check this out. Instead of passing a scalar value for the stroke width, I can now pass a function. That TypeScript function will run directly on GPU using type GPU. That function can describe any arbitrary curve that will describe the stroke width of the path. As input parameters, we get rich geometric information that will allow us to build incredible effects. Here, for instance, we set a wavy pattern to the path based on the arc length of the path. Part of the rich geometric information we provide, there is also the tangent of the path.
So t is the distance along the path? Okay, this is the t parameter, this is not time.
Path which we can use. Here we set the stroke width based on the tangent of the path.
Is what? Right. Oh, it's picking out a direction and doing cross product? Not cross product. What is this?
Pretty cool, no?
I think this is some sort of
Finally,
cross
we can
product.
assign animation values to these functions that run on GPU. Here we have a progress value that we can synchronize to create an organic stylus effect. Now let's add some colors. In regular 2D world, you can set a unique color or a crude gradient to the path. But again, here, instead of a single color value, we can use a callback function, which will be compiled and run on GPU. I can, for instance, set the color based on the arc length of the path, giving me this beautiful gradient.
Amazing. Totally impossible in Skia.
Beautiful self-intersections. If we were to draw the path using a distance field, this is what we would get. But we have the rich geometric information to the drawing, namely here the path arc length, that allows us to automatically deal with self-intersections. Another information available is the distance to the path stroke. Here, for instance, we can add a nice center line to the path. Finally, we can also use the tangent of the path to offset the white center line, giving a cheap physical rendering effect. Again, we can bind any animation values to these callbacks. We can use the progress value to shift the color gradient and fade the centered white line. Isn't that renderful? Now, these paths, they have one more trick up their sleeve. I mentioned that we nicely deal with self-intersections. They actually support opacity and can be blended with one another. This is particularly handy for physics-based renderings, such as this one. When Apple released Liquid Glass, all programming communities had fun replicating the effect. And that effect is based on rich geometric information. The way everyone worked around the problem, including us, was to use simple shapes. But of course, now that Redraw provides us with rich geometric information on any paths, you can use any SVG path you would like to apply the glass material to it. And of course, you can build any physical-based rendering effects on these paths and even non-physically based renderings. These are the Bezier paths we know and loved, but infused with that rich geometric information. In 3D software, you have arbitrarily complex rendering capabilities, but your input primitive is really hard to harness. In regular 2D software, you have wonderful path primitives, but the rendering capabilities are extremely limited. And I just love the idea that we can now bring rendering based on rich geometric information to Bezier paths, which are such an ubiquitous primitive. So far, I've only showed you open paths. Let's have a look at closed paths.
There is a lot of nuance in rasterizing a path reasonably. I mean, the speaking number of like accuracy, how many points. I wonder how this is done. For me, Skia is doing all of this. I just say, oh, I want this many points with those curvature, and Skia picks this reasonably. I was trying to do this manually, but it always ended up with some very hairy code.
I can draw a path here, and I can have a nice PB.
I wonder how this is done here.
On it. I can do also something a little bit softer as well. Now here's the kicker. I can blur the shape, but this is not a blur, it's a vector.
I mean, this looks like SDF, actually. Native.
Vector feather. There are no rasterization steps here. Let's use that blurred shape into this beautiful animation. Now, an animation, even as simple as this one, can easily drop frames on low-end devices. But of course, here, because we don't use any raster blurs, everything is very fast. Now, you can use vector feathering to build beautiful, soft, shadowy user interfaces. Again, an interface such as this one can...
When he says vector, it means that he's sending a path, the GPU, and on the GPU, the path is converted into a mesh. And all of the key points on this path are discrete points in the mesh, kind of. And because they can be, spaced, and the GPU natively interpolates between mesh values, everything is smooth.
Quickly get slower on low-end devices, but not with redraw because there are no rasterization steps involved. But I think that there is something much deeper going on here. Let me show you. Raster effects are slow and handcrafted. You need to build all the details manually. Now, some commercial products have long understood this problem and support vector feathering part of their offering. And they want you to rebuild the whole physical world yourself. I've watched many tutorials where you see industry experts painstakingly rebuilding the whole physical world themselves, one shadow at a time on every single shape. I do not believe that this sets a realistic expectation for developers and designers. What I believe is that instead people are going to build simple and flat user interfaces, such as this one, and turn a knob to set the temperature on how realistic they want the rendering to be. Many people are going to learn to tasteful soft shadow rendering, and some might even build non-physical based renderings. Vector feathering is an incredibly powerful feature, but also because we keep that rich geometric information available, you can use it to build advanced physical and non-physical based renderings. We all have special relationships with raster effects. Now, what we did here is to ask the question, can we build similar effects using vector information instead of raster information? And we found some of the answers to be deeply meaningful. I'd like to show you a few examples.
Okay, interesting table.
Raster information. And we found some of the...
Alpha coverage modulation, okay. It's alpha blending? Is it just a fancy term for alpha blending? I don't know. Analytic surface now. Okay. Okay, so those are just equivalents that can be used to achieve the same effects. So surface offset.
The answers to be deeply meaningful. I'd like to show you a few examples. The first thing is that, of course, the feather is variable. The same way we can set a curve for a stroke width or a color, you can set a curve for a feather value. There are different kinds of feather effect. For instance, here we use a glow effect, or you can use a linear feather. This enables a new use case for real-time user interfaces, analytical motion blur. So here I can move my sticker around, I can give it a nice motion blur effect. I am exaggerating here for demo purposes, and of course, on top of the motion blur, you can add chromatic aberration. Here I am using vector feathering to build a backdrop filter. In regular 2D world, these are built by creating a new surface for each layer and doing raster, effects, plus composition.
Yeah.
But in these examples,
It hurts.
everything is computed in a single pass. This means that you can stack as many backdrop filters as you would like, and it won't affect performance. Now, to be able to show you all these demos, a couple of things needed to happen. The stars needed to be aligned, so to speak. And the first alignment is, of course, WebGPU. And for two reasons. First, WebGPU provides us with a unique...
There is one thing I do not understand.
But in these examples,
This
everything is computed in a single pass.
uh,
This means that you can stack
stacking multiple blur windows, kind of. This suggests to me, because the GPU doesn't really have information about stuff that's above or below. This must be done on the CPU then.
drop filters as you would like, and it won't affect performance.
And it won't affect performance. Okay, the blur is not really different between them. This blur on the top one is the same.
You can stack as many backdrop filters as you would like, and it won't affect
Oh no,
performance.
it is different.
Now, to be able to show you all these demos, a couple of things needed to happen. The stars needed to be aligned, so to speak. And the
I have no idea how this is done. It's beyond me.
performance. Now, to be able to show
I'd assume blur processing done with free compute there.
stars needed to be aligned, that you can stack as many backdrop filters as
So this effect, I mean, it is easy to achieve. You just you first render the circles, and then on top of the circles, once you have the full texture for the circles, you can draw other rectangles, and those rectangles will use the MIP-mapped image of the circles to very quickly draw blurred image. This is fast blur. You can also do Gaussian blur, but it's super slow. So you can do this. I'm not sure if this is Gaussian or... In any case. And then when you draw the next one, you start from the bottom and you draw them one on top of another. Eventually you end up with this. But those are multiple rendering steps, and each one of them adds extra... Basically, it's another render pass that has to happen. You need to take this texture, do MIP mapping, draw, do MIP mapping, draw, do MIP mapping, draw. Or you can have a shader which will sample the texture without MIP mapping. That's also an option. And he says...
as you would like, and it won't affect performance.
He says that it won't affect performance. So this must be done in a different way. I wonder how that works. So I assume there is an overhead for each rectangle, but this overhead is probably not, another large texture.
Hey, Piangchen.
So you think that the description is made up? Maybe.
Now, to be able to show you all these demos, a couple of things needed to happen. The stars needed to be aligned, so to speak. And the first alignment is, of course, WebGPU. And for two reasons. First, WebGPU provides us with a unified runtime across libraries, so I can focus on building my own delightful primitives. I don't need to rebuild the whole world. These primitives are going to integrate at zero cost with existing libraries such as Kia or WebGPU. For instance, here we have a beautiful text layout rendered in Skia, which includes the native font rendering, and I can render a redraw path and nicely mask between the two. Isn't that cool? These are zero-cost integrations. The second reason WebGPU is so important here are compute shaders. WebGPU has two pipelines, a graphical pipeline and a general-purpose compute pipeline, and here all the demos you've seen are used using compute shaders. This is not a new idea, of course, but I thought this was really fun and almost cheeky to think about what would happen if we build graphics using the non-graphical pipeline. And I found some of the answers to be extremely compelling. Now, a second alignment here is that at the heart of redraw is this ability to pass functions as parameters that will be compiled and executed on the GPU using TypeGPU. And to tell you more about it, Ivo Plaza and Konrad Reshko from Software Mansion.
This I'm not interested. This is just translation of TypeScript to GLSL.
And we're part of the
Or
stops and blend between them with the standard mix function. If we instead wrote this function using Wigzil, we would have to concretize the length of the array, the function,
which can accept a color hex code or a CSS color. Both of these features are
shader up into multiple functions or even multiple NPM modules. As we build out new tech demos, we collect functions that we think might be useful for others and package them up as new libraries. Let's name a few that you can play with today. TypeGPU noise gives you pseudo-random number generation, similar to math.random, and procedural patterns like Perlin noise, which allow you to express organic-looking patterns in your shaders. TypeGPU SDF gives you access to distance functions for lots of shapes, commonly used in rendering crisp UI or geometry that is hard to represent with polygons. And there's many more, with lots coming in the future. And while Redraw is built from the ground up to work with TypeGPU, you can also use TypeGPU shaders with other libraries like Free.js or Pixie.js. Check out our integration guides on typegpu.com.
We are really happy to be a part of this new project. A tool that feels as familiar as React Native Skia, but opens up new possibilities in terms of effects and composability.
TypeGPU out. Back to you, William.
Thank you, Konrad and Ivo. This looks really cool. I really love that this is a bundling dependency. There are no heavy runtime dependency needed here. No.
I skipped most of this TypeScript on GPU part, but they mentioned a couple cool features which are, I think, genuinely useful. The primitives for noise. This is so useful. It's just nice to have them always present. Otherwise, every single shader that I write starts with the same primitive functions that I believe should be just part of the standard library or something.
No heavy runtime compilation step.
And they can optimize them better than I can, probably.
And of course, when writing shaders, operator overloading is very important. And there's something funny happening here. When I got started with Can It Be Done in React Native, a huge part of the series was reanimated. And Software Mansion came up with a way to execute and compile JavaScript code on any arbitrary threads, which was a huge part of the series. So it was only a matter of fate that when starting to fiddle with GPU primitives, Software Mansion came up with a way to compile and execute JavaScript code to the GPU. With Skia and Reanimated is an optional dependency, but of course everyone is using it, and I think the same is going to happen here. TypeGPU is an optional dependency to redraw, and operator overloading is as well optional, but I think that everyone is going to use it. And that's what I wanted to show you this morning, a new grade of 2D primitives.
Yeah, it's this is a breakthrough API. It's finally liberating web APIs from the Canvas prison.
And yet we keep the API as simple as the Canvas 2D or Skia API. A key innovation for us to provide you with such a simple API is of course TypeGPU that allows us to compile and execute JavaScript code on the GPU. And of course WebGPU with compute shaders and providing us a unified runtime across libraries such as Skia and Free.js. Now, as you can imagine,
I need to start this. This is on GitHub, right?
Such as this one, we needed a lot of time and space, and this wouldn't have been possible without your support. So this morning, we would like to make Project Redraw available as a technical preview to all starsreactnative.dev subscribers. If you were a past subscriber, contact me and I will give you access to the project, let me issue a heartfelt thank you to the community. These initiatives couldn't be built without your support. Now, when opening up a new area of work such as this one, I have so much more to tell you about it. And so I will, and I hope you can join me at AppJS Conf on May 28th and 29th in Krakow or live on YouTube, where I will deliver an update on React Native.
Sorry,
And so
Krakow, I
will,
can get there
and I
easy.
hope you can join me at AppJS Conf on May 28th and 29th in Krakow or live on YouTube, where I will deliver an update on React Native Web GPU and React Native.
I love it. I guess it's in May. We'll see if I can get there in time.
Here, as well as key insight about the Redraw project. So yeah, I am looking forward to talk to you soon, and until next time, happy hacking.
Hello.
Nice. Amazing stuff. Sorry, I need to share this. Okay. I will do a short break. Tune the music. And this, I need to save this. Yes, sec. And I'll do a short break. I'll be back in a couple of minutes. Okay, I'm back. I will have to digest this library. It's cool. I would love to see the sources. I was looking for them. I couldn't find them, unfortunately. It has to be a hidden repository or something. I don't know why. Why would anybody publish something and not open the repo? Anyway, I think this is going to be great. I will try to pull this into Automat. I know it's meant for web development, but I will see. Maybe there is possibility of translating some of the ideas from this library to native to C++.
What's the point of software without code?
Yeah, even if I wanted to start this on GitHub, I kind of cannot. I only have Playground. I mean, okay, maybe I could do something like switch the UI. Yes, I could do Control F12, and with Control F12 I could. My back. I need to find on which console I have my desktop now. 8? It's usually 8. 9.
Gen 2 killed itself.
No, it's just... virtual terminals, virtual consoles. You know, this Control-Alt F something.
Two?
It's usually 1, 2, 4, or 8. I was setting this up a long time ago, I don't remember.
16?
Am I not getting any output? Maybe I need to use Shift. How do you switch virtual consoles, VTs? Control Alt and function key.
To 16, you can get easily, but when it gets stuck on 32, that's pain. Yeah, Control Alt F key. Let me maybe SSH. KTRL Alt key.
Oh. I think something broke.
Have you tried Taiwan?
That's the first one. Yeah. They don't even show me the text prompt. I just get both black screens. So I think something happened. I do wonder. slightly concerning, honestly. This sort of screen going out, not reacting. Anyway, it will boot up in a sec. I hope. Yeah. I need to check the system log, the last dmask. Okay, I fired up Claude to figure out what happened. And I can get back to writing this new register widget. Okay, I will need 2 springs, one for register index offset and one for size offset. Sorry, not regular index, position offset. Okay, let's go to the function that draws the register. So we have those 2 colors, slightly darker, slightly lighter. Yeah, we will keep using them. So here we are grabbing the value of our registers. Maybe I should log the assembler. It's not super important. Okay, this is very simple drawing code. Where do we actually draw the rectangle? Okay, so here we are drawing the background using dark paint. I'm not going to do that anymore. At least it's not going to be a rectangle. This is the background. What is this? And the issue happened while Bitburner was saving stuff. This is not a bug in the game. This is... I wonder why this is corrupted. Can be our test register. This is a small problem with stack register and with memory in general in Automat. It's that whenever Automat restarts, it's not guaranteed that we'll be able to recover everything at the same positions as before. So it's possible that this address is going to be wrong. Who knows? Okay, I will deal with this issue another time. We only care about registers now. So, the shape. Base rect. Okay, it says 3 by 3 centimeters. This is okay. So this inner rect, I think we can replace with this. I'm basically removing outline right now. Oh, I could also animate the flags. Okay, so our register no longer has any outline here. Good. Now we want to add a series of let's just call them shapes. I need one more. I need two more colors. So, on the left, I would like to have a nice border. Where the flag turns around. And this will require, I think, more than one shape. I will do it like that. If we are drawing the last bit, we are drawing the flag, this is going to be different. I need to use Path Builder. I could actually pre-compute all of them. Okay, from this we need to do yeah. Right, contained by the tangent first. P1. Okay, so P1 is the first control. Okay, we are going to plus Bendar. And then I could insert arc here. Don't think arc is necessary. I will do a straight line. How do I turn this into a path? Builder, detach. Let's try this. Okay, it's not working. Oh, because I'm not drawing this? No, I am drawing this. If bit equals 7, maybe I will use a different paint. Hey, there is something blue here. It's just we cannot see it. What is left? Where does left come from? Oh, I know. It's because of the shape. Let's go to shape. Okay, temporarily I will just make the texture 1 centimeter larger so that I have space to play. Yeah, this is the shape I wanted. Just the color is wrong. Where is the new color? Yeah. I guess I should probably fill this with some kind of gradient to indicate that it's turning around. I have this adjust light. Oh, I can do this. Next, I want to create a gradient. I do not have gradients. I do. linear gradient. It takes 2 points. Then this SK gradient thingy. Yeah, SK span for colors. Okay, and that should draw a nice shade in the left. It's quite a lot of code to do a simple gradient. Yeah, I think this is good. It's not perfect. I think it's acceptable. Okay. And I think we also do this. If this is the first bit, and not the first row. Maybe that should be plus here. Yeah. It's going in the wrong way. We need this. That should help. Okay, looks better. Now the register has some depth. It also has some gaps. We have to figure out what to do with them. Next, I think here I should add the backside of this flag. This backside can really be drawn first, because it's kind of in the depth order, it's behind.
Wojdalovetsky says.
Hey, to be a simpler curve. Here we go. Start. Oh no, I need 2 tangents. Is this API? I'll just do 2 regular lengths. I need to insert variable names because I'm getting confused myself. This radius here will be useful. Something like that.
Meister Chica says.
I managed to get slogging going on in CPP Gotch Kale.
Slogging? Is this some variant of slopping? What,
URL.
slog.
Half-slopped logging. Most important part is in event.
No macros? No macros to construct nice messages? Wow. Such a nicely organized code. Separate file for an enum. I do not see this very often.
You call logger. Level dot.
Wydodovsky says,
What time do you usually stream? I'm currently developing my own game after work, and I think watching your stream in background could motivate me, especially with my ADHD XDD.
Nice to hear. 3 times a week usually, but recently I've been skipping some streams. Actually on Twitch I have a schedule, so 3 times a week, Monday, Wednesday, Friday. The time shifts around during the year because of my time zone, which tends to move. But in my time it's 11 AM to 5 PM usually. So generally work hours, standard work hours typically. Oh, this logging library, I really like this trick with default initialized source location. It's such a nice hack to get implicit source locations everywhere. This time is another one. Oh, so you call logger.trace and then stringer. I'm not sure what stringer does. Here. Probably in the implementation. But it appends some message, I guess. It's a Fluent API, so it chains the event. So this is an alternative to format, I guess.
Meister Chica says,
String is an object in Go code that implements string method.
Okay, I get it. So you can just pass anything here that can be converted to string and appended to the log message.
Stringer tower.
Funny. So what I usually do is I alias formatting function to F. So I have F. And I just use formatting function everywhere. Standard, std format or fmtlib, I don't remember which one. When you alias it to a single letter, actually using those formatting function, it's it becomes actually almost as convenient as Python, because it's just a single letter and a pair of parentheses. And then, yeah. Nice.
Messy part is in.
URL.
the secret str. Hey, you even have formatting, comma, key value, wow. It would be nice if switch had case ranges or something like that, so that this if would be folded into this switch. Yeah. Some languages have that.
CP has it too with implicit fault-trough.
Yeah, but you have to enumerate 20, options in 20 lines. The switch, the if statement was probably cleaner. More readable, I guess. Non-existent packet. Also. Oh, it exists. Something is happening here. This weird color. Let me just draw it in black. Let's see how this will look. Okay. It was just too bright. Should be fine. Speak this to be something like that, maybe. Oh yeah. Oh, here, back here. Okay. It was a vertical gradient instead of horizontal. It's funny that the letter is drawn between the, I think, literally in the middle Technically, it's maybe it's even accurate. Then what's the depth of those things? Right. Now I want to add the top part of this flag, which should end here with this fancy wavy shape. Needs to be drawn here as well. Actually, I'm doing a lot of those moves up, down, left, right, and I think I could actually add methods for this. Okay, this is basically the same code. It should be more readable. Those are very nice helper functions. Surprised they are not part of the standard. We have the points, we can build the path. Okay, so this moves to the bottom left of the circle. We are doing the circle with those two arcs. And I need to do a long line going all the way to the right. And now let's draw this. Draw... with black paint for now. Nice. Just the drawing order needs to be changed a little bit. So this will be drawn after the back sides. That's one way to crash Automat. Delete the assembler which owns the register. Okay, color, first color. And a big chunk of this could be pre-computed. I'm not sure if it's worth refactoring the code. I do not see color. I know why. Okay, it's not bad, not bad. Maybe... yeah. This should straighten the bottom line of the flag. Yeah, like that. I still need to think about the layout. I guess I can fix this edge here. Cool. So the idea is that this section on the left is going to be draggable, and it will allow me to resize the width of the register. This will allow me to resize the height, the size of the register. So this is at maximum now. I will be able to drag this and move it down, shorten it. Those letters, I think I need a background here. I can also put an editing widget at the bottom. Let me do that now, so that I can edit the values of registers. Super nice. It's way too large. This needs some design work, honestly. I will add the editing widget, but about the shape and position of, hex numbers, for instance. I'm honestly not sure if hex numbers are necessary. Maybe they are. Maybe it's good they are here. Because I need a good place to drag this thing. Okay, maybe the icon. Maybe icon could be a place to drag this. Yeah, I'll just add this editing widget. Okay, so instruction implements this buffer. I guess this buffer is what's used for the editor, the buffer widget, yeah. And this is an object and a buffer. And yeah, this is complaining because we didn't implement all of the virtual methods that we need. Yeah. Let's implement all of the buffer options, like buffer visit. It's going to be very similar to this set text. It gives me a reference to U in 64. I need to convert this into a char pointer. Okay, so register now should function as a buffer, so it should be editable. I just need to create a widget for it yet. Okay, builds runs. Cool. So define the register widget. Register widget is now going to have an editor. Needs to be initialized. And I need a pointer to this buffer thingy. Actually, looking at the API, I should not pass those pointers. Me. Maybe it's okay here. Okay. I really need this cast. I don't. Okay. I should add visit children. And I also think I need to draw those children explicitly somewhere. Somewhere in the center should be drawn the text area. It's not being drawn. Something is wrong. All this after setting fonts. Okay, I will just copy this initialization. It's very weird that it's necessary. Those fonts should be default. Anyway. I see that fonts are typically implemented in CC files. Maybe it's such a lightweight thing that I should have many fonts all over the place. I will just export them. This needs to be prefixed. It's different. Yeah. There is our value. Ah, here's the register. Okay, this text editor, it's slightly weird. It's not working as nice as those. It's slightly larger here. So I moved the origin, the bottom left. So the origin of this text box is here. I do wonder, where do I want to position it? This way I can just center this widget horizontally. Probably move it down as well. Kind of center. So this mode should really be tweakable. So when I click this, it should be changing the vertical position also. And be right back. I'm pretty sure I need some background for this register. This pill-shaped object, it doesn't quite fit with the flag idea.
Oniet says,
Hey, Math, sup?
Hey, it's going nice. We're doing the same stuff as usual. I mean, we tend to do different things, but yeah, we are back to graphics, UI design.
Relatable.
UI design is honestly the only place where AI is still much useless. I really wish it could, you know, they can write pretty nice web pages now, but when it comes to brainstorming, they're not so great. Anyway.
I finally got a working Voice C implementation. Still adjusting things though, but it's finally something.
What it can do? I mean, apart from just generating TTS, right? Does it have some fancy control over some voice parameters? Let me open design.
So there are multiple parts. I separated Voice-Init and the actual application. Voice-Init itself can clone voices, and it can generate voices with cloned voice instruction.
The instruction is in natural language. Initial design was so much nicer than what we have.
Yeah, adds a bit of time to generation. But you write an instruction for a different model to adjust the style.
Shape is nice. This is working. We could add this subtle top-down gradient, maybe. I think there is a better place to prototype the register design.
The application itself, though, is made to connect to StreamerBot to catch triggers. Then you can set up overlays. The overlays themselves go to OBS as a browser source, and visually you add boxes, bind triggers to those boxes, and sources, which can be image, video, text, TS, etc. way.
I know overlays, I mean those browser overlays, but I've never used triggers. So OBS somehow, so is this kind of integrated with OBS beyond just playback of the sound?
As far as OBS goes, it's just a browser page. Application creates the browser page and connect to the application via WebSocket or device.
Yeah. Initially, I thought that there is some sort of deeper integration.
Then when triggers get caught, we push data via WebSocket to display visuals or sounds.
It was like a decent TTS system at this point.
Kinda disliked the way I couldn't make it cleanly in a source streamer bot.
It is definitely possible to make it cleanly, it's just it requires access into OBS internals, probably. So this is our beautiful register. It stands now.
Well, you can make it semi-clean, but I don't like temporary stuff just hanging around. I actually made a script on StreamerBot to add a temporary source, run a timer, and then remove it. But StreamerBot arguments are a pain in the ass since they are shared.
Let me check what StreamerBot. Oh. Nice. Seems fancy. My streambot is just a black terminal window. And it just prints error messages every now and then.
Mao, it is really good piece of software, especially since you can run in line C.
And it's downloadable. Okay, this is nice. It's not some kind of online service that you have to pay a like monthly fee.
Yeah, it's fully local and fully free.
Nice. It's weird that it's on GitHub, but it's closed source. Which speaker? Check this out. 4 years ago. I guess some kind of TTS system.
Yeah, they hid the source code XD.
This is suspicious. I mean, why?
Well, you say why, but then again, while I do plan to make Kosovoisenet public when it's done, I don't plan to do the same for the application. What?
I wonder if this source hiding has anything to do with AI agents, because AI agents, like typically when you have an application, you can generally publish it as under like very open software license, like GNU or AGPL, GNU GPL or GNU AGPL, and then it's really hard for anybody to steal this because it's for free on your site, and anybody who makes modifications also has to make them free. I do wonder if AI agents, because they can take a look at open source software and kind of clone it, if this is causing people to hide the source code. Yeah. Anyway. My streambot is open source. I don't care. It's not very valuable.
Meister Chica says,
CTRL verfivi.
Onios says,
Could be. I think they hit the source code around the time they announced one. Hid.
Yeah. It's a little suspicious, but then and there's quite a bit of software that I use which is not open source at all. It's probably not a showstopper. So this is how the register looks right now. Much. Is this? Is this mouse? Did I draw it? Yeah. So in this box we have some text. And an icon for changing the register type. I need to redesign this so that it kind of fits together. Like right now this hex is actually overlapping with flag a little bit. And this bottom text is kind of misaligned. So this is what we have right now. I think I need some kind of background. Some kind of background will help a lot. But the flag, which is waving in the wind or like twisting in a very weird way, this very weirdly twisted flag. Prevents a clean background. Let me see if I can... Maybe if I increase this radius here quite a lot. Affect this radius here as well. I could make the bottom ribbon larger, and then I could squeeze the text on the bottom, on the top bar. And maybe for these hexadecimal values, maybe I could put them like here. No. It would be easy to confuse.
Oh, BW. As far as speed goes for Kosivashi remembered, we talked last time with CUDA 5's TTS takes. 5s to generate.
Decent. Yeah. It probably also depends on the GPU, right? There are probably dramatic differences between top GPUs. At least this is what I observed. Like in the past, when I was using 1080, GeForce 1080, TTS generation was exactly like you say. It was generating. I'm using Tortoise TTS. It was taking the same amount of time to generate as to play. But now that I have a beefier GPU, it's like, I don't know, 4 times faster.
true, it would. I'm running on 5060 Daito.
Corncake C says.
Hello, sir. Would you like to review my website? I am a developer from Indonesia introducing AI Builder, but the website is in Indonesian. I hope you understand.
Thanks, I'm not interested. Although I've received so many... what was this? Those were artists with some assets for streamers who were asking for portfolio reviews. I do wonder, is this some kind of like marketing strategy? Asking for reviews?
Onyet says.
Oh, the artist, God. I ignore my kick stream for that amount.
Cornex CC says.
The website is like a Visual Studio Code-eyed. You can create a website or web app with our AI.
Onyet says.
9 out of 10 times in my kick stream, it's either a bot or an artist.
Yeah. Would be the case here as well.
Don't even know which one is worse at this point.
I have idea what to do with this. Maybe I can just squeeze this. It will be smaller, harder to type. But... sorry, I'm just busy with other things. I can probably add something like that. The text over here. And maybe it could even be... sure. That would be strange. This whole flag thing is already kind of strange. I should not complicate this shape even more. I think the most natural position for the editable field is on the bottom. Do I need something else? maybe... No. I was thinking that maybe I could have a line imitating like flagpole. And from this flagpole I could actually hang multiple flags. But I think the idea here is that flags are a metaphor for bits, because bits are toggleable. I should not use this flag willy-nilly everywhere. It should only be used where bits are present. Wait. It's more of them. Where do they come from? Kind of background can I draw around the flag? It's too much white. I will think about this. In the meantime, I've started thinking about this, and the way my brain works is that even though I can do something different, I'll probably do some coding. In the background, the solution should arrive. So, inside register, I need to store this buffer type. My register needs to implement those functions. That was very easy. This is the widest possible hexadecimal string. And this is the widest possible decimal string. Way too long. I crashed. Anyway. So this text field, it's incredibly long. So this is the default size. Things are pretty small already. Maybe this register icon could be more prominent in this design. Maybe it could be very large. actually, yeah, I think I will integrate these hex values into the checkerboard. I will just use a different background so that it's clear that they are separate entity. It will solve part of the background issues. Maybe new background is not necessary now. here is an even different design. I could put the text on the back side, text, the editor widget on the back side of the flag. New design, I will move all of those to the side. And here I will have a block for good with yellow, with gold, maybe some kind of reddish. Green, yeah.
Doma903 says,
Hi, is it possible to automate ets through roots using Automate?
TTS? Sounds like this, like ECTS. Absolutely. I mean, absolutely. I was testing it in Kingdom Come Deliverance. It's a game where it's an FPS game. But in some sense, Euro Truck Simulator is also FPS. So if you can record macro long enough to do the route, between two places, you can probably just loop it over. And there is a good chance it will work. The only problem is like drift over time. So you need to kind of find a good way to reset the position of your character reliably, so the character or the truck starts in the same position. If you can do this, then yeah. Then I think it's possible to create a macro that will kind of drive you back and forth on the same route. I actually have a demo of Euro Truck Simulator, I think. I should try this. Oh. Oh, thicker. Needs to be thicker. Anyway, if you try to automate it and have some issues, you can let me know, because I think it should work. If it doesn't work, it's probably a bug. I need to remodel this part. And the plan here would be to squeeze the register, the editor widget in here. Or maybe, because writing on the back side of the flag is kind of strange if I'm using the front side. I want to have a variant where I'm using the front side. And in this variant, we will also put the icon on top. That's alright. Yeah, make this scale accurate. This needs to be about this large. from here. So in this variant, there is a hole here. In this version, the pole is somewhere here. Or maybe I could put this guy on the bottom. It would be a nice decoration here. I would have to generate new images that would fit the hole. That could work. Oh. One thing missing from this design, and it's the text field. We need to allocate lots of space for this text field. Suddenly makes the widget very unbalanced editing field. One more design maybe. If we add... So this design is actually the most balanced so far. this one here. And this design is actually almost identical with our current. We just need to extend this, tweak the colors. I need some background for this thingy here. Okay, I have an idea. I was thinking about redesigning this assembler thingy. I was thinking about different elements of this design, and a lot of them are nice, but I think there is a better use for the stars and the dots, those Broadway lights around. I think we could use them, for example, the stars, I think we could use in the background behind everything. That would be fun. We could pimp out this shader. This is done by a star shader. It's not a flat bitmap, actually. Those stars, they could actually move and animate. The dots, same. I think they could be used to convey more information. We're not doing this right now. I think we could use them elsewhere. I think assembler would be redesigned kind of from scratch. And if assembler is redesigned, then there was this nice element somewhere. If we open up Krita. Okay. There is this texture, which are very much like, and it kind of reminds me like the stone, something that's, you know, computers are kind of like stones. They are made of silicon, so I think it would be kind of fun to use stone as the material. It will be hard to find this specific texture, though I think this texture comes from somewhere. I think this is a texture that was built into Krita. Yeah. I go to layer style, then overlay, yes, this is texture from Krita. So it's probably, you can probably get this from Krita assets. Cool. Yeah, I think I could use something like this. So the assembler will actually be a block of stone. kind of fixed. The same way that your CPU is fixed. It's not changing, it's not shifting. You are not really creating new registers or destroying them. They are there. And even those nice pictures that I think we could basically design this to put just all of the registers in this shape. Or something like that. I mean, not every of them, because most of them are not accessible. We cannot really check the those like OS registers. But I think most of them, those, except maybe instruction pointer, we can display. Okay, we can also display instruction pointer. Yeah. I think we'll try to redesign assembler using those to show the full state, to show the full, quote, user context. This is how it's called. The state of registers, the complete state of a running program is called user context. I think we can redesign assembler to show its full state. And the key design element of this register is going to be stone. This warm, nice, polished, slightly shiny stone. And if this is the case, I think this editing field will be made out of stone. Maybe grayish, say like that. Can I do this? Probably not. Maybe I should. I think if how should I align this? I like this new design way more. I'm deleting the old ones. There are 6 variants I still want to consider. With these centered. Aligned to the left. I said 6 variants because it's also possible to shift those numbers to the left side. think the ones which are aligned to the right look nicer. I think that maybe in this variant I could also align text to the right. That could be a little confusing. And maybe I could make the register swappable. Maybe I could add a select field here, similar to how some instructions have them. Jumps. Yeah. I could have this sort of selector. I don't remember if I have a decent API exposed for this. Okay, there we go. I have this enum knob widget. I have a widget that theoretically should allow me to scroll through things. So I could scroll through register indices. So theoretically index register widgets could be resettable. I should be able to pick them, right? That would look. I wonder on what sides do we typically show hexadecimal values? So the way that XXD works, XXD is just a hex printer, is that it shows address on the left, then hexadecimal values, and then ASCII. This is how looks the output from XXD. I want to stay consistent with as much of the existing software as possible. By consistent, I mean that everything, the layout of interface should be similar to layouts of other similar interfaces. Okay, I think this is the way. We'll have right aligned. With hex on the left. And this icon move this over. Okay, I think this would work. We're almost there, actually. Where do I put the origin of the register? That's an interesting question. On 0, 0. If I imagine this, when I scale it down, nothing. What is the center of the mass of this object? Here. if this scaling could work. Like that. Maybe here. Yeah, I think this one is right. Maybe just in black. I think those. I think this is the way. This is the way to do registers. And new assembler is not going to have embedded register, at least not this form. The default assembler, I think, is going to be a large slab of stone with all right. Maybe something like this for all the registers. I think I can change blending mode. Okay. So many registers. And those are just general purpose registers. This does not include the MMX and AVX registers. They're going to be huge. yeah, essentially the whole context, like the state of the running program, it's like 1.5 kilobytes, and it's like a page of text essentially. I think that maybe we could even have some sort of, because there is stack also within assembler. Assembler has some kind of built-in stack thingy. So maybe we can also visualize this stack somehow. The though stack grows from the top, so maybe I should draw this like that. And otherwise, this assembler is going to be kind of similar. It's still going to have a hand pointing at the current instruction. And maybe it will not have these those spotlights, or maybe spotlights will only activate on hover. But okay, the priority is probably to redesign the register widget. This is the one that's of important. By the way, we just added the possibility of setting values for registers. It was not possible before. The only way to do this was to find the move instructions. There was no move. Move was the only way to set register values. Okay. Still some crashes to figure out. Anyway, I am saving this because it's getting kind of late, and at this point, I have to think. So we'll continue this on Friday. On Friday we will try to implement as much as possible from this design. I think actually the whole design is going to be possible. I don't see any big stoppers. We'll probably also even implement this nicey switcher. Alright, so see you in 2 days. Bye bye.